Welcome everyone to our webinar on the internationalization or on ADLS International. My name is Felix Weiss. I'm the head of sales for LightGuard. We could also actually call this webinar LightGuard and Friends. We have a lot of speakers here today from either sister companies or partnership companies. One from the Netherlands, one of our speakers is from Italy. We have Senchas with us. In the beginning of this webinar, I'll give you a quick introduction to the purpose of ADLS. Then Lorenzo Ema, one of our business developers, is going to talk about Germany, Austria, and the UK and their developments. We then have Daniel Dubbelhuis. I hope I pronounced the name correctly. I still struggle with it after all these years. From the Netherlands, from Topwind with us, and Tobias Bröning from our sister company Accenture. And then in the end, there will be a Q&A, which will be moderated by Magnus, our head of marketing. We're very happy to welcome you here. We've seen guests all the way down from south from Greece to all the way down up to the north of Norway. And we're very happy to share our knowledge with you, and this is also the moment I'd like to start. What is the purpose of ADLS? What are we talking about here today? By now, there are a lot of wind turbines everywhere else in the world, and they can be seen because they have blinking lights on top of them. So we know that the turbines have to blink, but the big question is, do they really have to blink all the time? And in order to evaluate these questions, we have to look at what a wind turbine actually is, or why there are beacons on top. A wind turbine is considered a building like any other building too, and any building that reaches into airspace is considered an airspace obstacle. Usually this border is right around the 100-meter dash line, and we can see over the last couple of years the wind turbines have been getting a lot taller. So as wind turbines get taller, they need these beacons. And the reason they need two most of the time, and the reason why they blink, is because other than a usual building, a turbine is not a fixed element. It has a rotating rotor, and so the tip of the building is not constant. Let's say the Eiffel Tower has a fixed tip of the building, the wind turbine doesn't. And so that's why the blinking lights are there to warn even more of a rotating obstacle. So why ADLS then, or where does this idea come from? Regarding wind turbines, we basically have three interest groups or three interest industries. One is the aviation. Aviation industry is concerned with the highest amount of safety they can provide. And so they would like to have all turbines blinking, or all turbines be equipped with beacons all the time. Then we have an interest groups, the residents or nature alike. They have an interest of being kept from emissions. So they don't want to have any light emissions, or at least not a blinking one. And then we have the wind turbine industry in the middle, who tries to satisfy the needs and the demands of these three different interest groups, and tries to be a mitigator, to come up with a solution that finds a solution for all these interest groups. And this is where we are situated at. The ADLS suppliers as a system integrator to the wind turbine industry, trying to find an appeasable solution for all these parties. So ADLS is a technology that monitors the airspace around a wind farm and only switches on the lights in case it is really needed, because if there is an airplane present. In theory, these can be achieved through different technologies. I can either listen to the transponder signals that all aircraft carry on board. I can actively look for airplanes in the sky through a primary radar, or, and this is most of the time not an option that ADLS providers have, I can actively interrogate the transponders on board of the airplanes. This is rarely permitted though. So far, we've only seen it in Norway. And then the question is, what kind of technology do I apply as an ADLS provider? In theory, there are some international guidance or technical laws that prohibit, that enable the solution, that allow it, and that only prohibit certain design standards, but there's no specific rules because every country has their own rules regarding aircraft, their own rules regarding the flight plans and the rules that the aircraft have to obey. And also each country has their own rules to how an aircraft obstacle like a wind turbine should be treated. So what we see at the moment is that even though there's some international guidance, each country has a very specific approach to ADLS. What we also see is that there is a big rise in demand for ADLS, and it's mostly driven from two environments. On the one side here, we see more wind turbines worldwide. Turbines are getting taller, and at the same time, the aviation industry is requiring a more strict ruling towards the beacons, often meaning that the beacons have a high intensity of the light, or that there are more beacons placed, for example, on the towers as the turbines get taller. This results in overall more light pollution. We also see that as more wind turbines are being built, they're getting closer to urban areas, and at the same time, the environmental regulations that wind turbines are obliged to be restricted to are getting more strict. And so we see two developments that actually pull in complete opposite of directions. There's more light pollution, and at the same time, we see also a demand for less light emissions. And this is where ADLS as a feature comes in as a mitigation measure. And the key features for this technology in the upcoming years will be that it has to be a safe technology because otherwise the airplane industry or aviation industry won't permit it. It has to have a high quality because otherwise the residents and the nature bodies won't be satisfied. And it has to have a high affordability because otherwise the wind farms, the wind turbine industry does not allow it or doesn't build it. So this is the basic background. This is the philosophy. And now I would like to hand over to our speakers. I'm very happy that they're here with me today. And the first one is Lorenzo, one of our business developers with the market Germany, Austria, and UK. Lorenzo, please, the stage is yours.
Thank you. Good morning, everyone. I'm going to talk about ADLS in Germany, Austria, and UK. Lightguard was born in Germany, and Germany remained its main reference market. And Germany is also the main country where ADLS was introduced, actually the first one, and the first one that made it compulsory. Legal situation in Germany. There are two important laws in Germany regulating ADLS. The first one is AVV or AVV 2020 that regulates the aviation. This regulation is derived from international standards such as ICAO, IE, and IEC, but it can be adopted by regional and local authorities. AVV defines the technical requirements for ADLS, for example, the brightness, the activation range, the data storage, the transponder modes, and the detection radius. And it also defines the civil aviation authorities and the certification bodies. So the framework for ADLS in Germany is set by the AVV 2020. There is another regulation that is important in this regard, EEG 2023, the Renewable Energy Act. In Chapter 9, it makes ADLS mandatory for all wind turbines in Germany. This is very important. So ADLS was made mandatory for both existing wind farms and newly erected wind turbines. Of course, there are some exceptions. For example, wind farms that are near to some critical infrastructures, such as airports, and old turbines, so turbines built before 2007 that are close to the end of their life cycle, so to say. But overall, ADLS was made compulsory in Germany with a deadline. The deadline was the 1st of January 2025. And importantly, in Chapter 52, there some penalties for non-compliance have been introduced. Some important penalties, some relevant penalties actually. So what we have experienced as Lightguard in 2024 was a rush for existing wind farms to comply to this ADLS regulation. Germany is taken as a reference also in other countries, but so far no other country has made ADLS compulsory. Yeah, this is our portfolio in Germany. We have more than 4,000 turbines under contract. We have installed more than 500 receivers, and we have turned dark more than 750 wind farms. And what you can see in the picture is also a graphical representation of the geographical distribution of our receivers, and also the multilateration areas that we have in Germany. The second country I'm going to talk about is Austria. So Austria has a very fresh regulation that was introduced between last year and this year. And in Austria, ADLS is permitted overall. So it has been introduced, a framework has been set, and ADLS is possible both for existing wind farms and for new wind farms. For new wind farms, it can also be demanded on a project-specific basis by national or local authorities. There is an important difference between ADLS in Germany and in Austria. So in Germany, we receive transponder signals from aircraft through our network of receivers. In Austria, this is not possible because the signals on lights off and light on are sent by Austro Control, which is a state-owned organization, basing on the air traffic. So we do not detect ourselves the signals, or other ADLS companies do not detect themselves transponder signals, but this part is taken over by Austro Control. And what Lightguard does in Austria is to offer a turnkey ADLS package that includes the upgrade of the wind farm infrastructure and beacon lights if necessary. For older wind farms, it might be necessary to upgrade the lights in order to make them be ADLS compatible. The standard requirement is that the lights are controllable to be ADLS compatible. We also take over the application process because for ADLS has to be requested to Austro Control for each wind farm. We install the ADLS server, LCU, and also we provide wind farm monitoring and reporting. On the next slide, we have a graphic showing how the system works in Austria. So on the left side, you see Austro Control detects or analyzes the air traffic, sends the signal through an API, so through an interface, to the ADLS server, the light control unit. The light control unit is connected with the SCADA system of the wind farm and therefore is able to control the obstruction lights. Moreover, a monitoring tool called OWL, Overview for Wind Farms and LCUs, is offered in order to continuously be able to monitor the status of ADLS in a wind farm. The next country I'm going to talk about is the United Kingdom, which is actually the most uncertain. In fact, in the United Kingdom, there is no ADLS legislation yet, although discussions have begun, and the Civil Aviation Authority is the responsible regulator. In particular, the Civil Aviation Authority is responsible for publishing the so-called CAP 764, Civil Aviation Publication 764, which you can see in the lower picture, that regards the policy and guidelines on wind turbines. A first draft has been published in 2024, and ADLS was contained in this draft. And according to some discussions that we have had with important operators in UK that have direct contact with the CIA also, ADLS is expected to be introduced soon, in the first semester of 2026 or even in the first quarter of 2026. There have also been some initiatives from the wind industry to push ADLS, for example, Scottish Renewables already in 2021. So there is a will within the market, within the country, to turn on the lights at night and have dark skies. There is an opportunity for operators to engage in pilot projects in order to reduce visual impact and improve the project acceptance among the neighbors. This is a good opportunity in all the countries. So to sum up, Germany, most important ADLS market, ADLS compulsory for all wind turbines. In Austria, ADLS has been freshly introduced. ADLS is possible and can also be demanded to make compulsory on a project-specific basis for newly erected turbines. There is also a good market response in Austria. We have noticed, talking to some operators, that it is something that they have desired for years, and also that can really improve the acceptance of wind energy in areas, especially in areas where there are some villages or cities. Last country, United Kingdom, ADLS welcome, and we hope to be able to give you some more details in 2026. Now I am happy to hand over to Daniel for the Netherlands. Daniel, the stage is yours.
Thank you, Lorenzo, and thank you also, Lightguard Felix, to be able to tell something about the Dutch situation. So I will mention something about that. Lightguard Topwind, we are the official distributor for Lightguard in the Benelux, mainly the Netherlands at the moment, and for selling the ADLS solution here. As Topwind, I think most of them you are not familiar with Topwind, but we are an all-round wind energy service supplier. We provide several systems to the wind energy sector. We have solutions for bats, solutions for ice protection, ice prevention, and so for ADLS, where we closely work together with Lightguard. And over the last 3 years, we have worked on quite some wind farms, which we have equipped with the ADLS system. You can see them here. I will not mention them all. Maybe for the Dutch participants, you will recognize some of them. So at the moment there are 7, and we are still in the contracting phase of others. So quite some activities here. And just maybe Magnus, one slide back. You can see, and there are small wind farms and the bigger ones. And in the first and the last one, 80, 90 turbines. So that's big wind farms, but also the smaller ones are there, as you can see. And also all kind of wind turbine types are present. And from Enicon, Nordex, Vestas, GE, actually all turbines are part of it. Yes, next slide, please. Here you can see some of our people working on the system. Here installing the antennas on a wind farm in the polder. And on the picture on the right, you can also see some of the antennas. So just a picture from the field, so to say. Next slide, please. Yeah, and Lorenzo mentioned something about the situation in the countries just mentioned. If you look to the Netherlands, we have aviation lights mandatory for wind turbines with tip height more than 150 meters. So the lights are mandatory, but ADLS itself is not mandatory. Different compared to the German situation. Not mandatory, but we see more and more and from the perspective of being a good neighbor, that the system is applied. I always say you cannot keep the turbines away from the horizon. Referring to sound, you can only minimize it to a certain level. But what you can do is shut down the lights during the night, and that is really appreciated by the environment. When did it start, ADLS in the Netherlands? Actually, that's since 2022. At that moment, there were, and by the end there were requirements available, in what way this system can be applied and what requirements you need to take into account. So that really brought a lot of clarity to our country, and together with the transponder being obliged in aircrafts, that together made it possible to roll out ADLS. And if you look to ADLS, we are a provider of the system, but we work very closely together with IL&T, and that is it's a supervisory authority in the Netherlands, and doing all kinds of things here, but they also are involved with this topic. And their role is to assess if a location is allowed to use ADLS. So they do checks on the aeronautical services. And like if you have an airport and there is a specific entrance of the airport for the airplanes, and ADLS there is not allowed, but in the surrounding it is. And for every project, we perform a flight test. So it's really an airplane testing the system. So conform a test plan. And so doing different approaches for the project to see, hey, does it really work as it should? And that test is also afterwards checked by them, and in the end they give the approval. So a very important body, so to say, and I think the cooperation is very good. Another point, as part of this 31 requirements, is that still a flashing infrared light is needed on the nacelle. We also distinguish two areas around a wind turbine. You have this detection area of 7 kilometers, and where it should be detected, the airplane. And we have a warning area of 5.5 kilometers around the wind turbine, where the light should go on. Another point is the yearly reporting of the system. So that's also part of the 31. Maybe if you find it interesting afterwards, I can also share with you this list. It's also available in English. And we see that more and more the system is applied, and the government and the provinces really push the use of the system, and they also do that via subsidies. So you can see it here. It's not that all the 12 provinces of the Netherlands provide it at the moment, because some of them say, hey, we have not so much turbines with high hub heights, but others are very active, and it means that you can get 40% of the capex subsidized, and with a max amount per turbine. But we see it's made use of this, and it's a good scheme to promote it. Okay, next slide, please, Magnus. Yeah, my last two slides are about the case study in the Netherlands. And you see here Windplan Groen. It's in the middle of the country. You can see it here on the map of the Netherlands. I also mentioned it in the first slide, or the slides before. It's a very flat area. It did not exist before the 50s and the 60s. So it's new land, a lot of agriculture there, but also a lot of wind turbines. And recently there has been a lot of repowering going on here. And you can see here Windplan Groen, a big wind farm consisting of 90 turbines with several clusters, also several owners. And this is a location where we applied our ADLS. And in the next slide, I have some details on that. So I start with the third point. It's we placed here 7 receivers and 11 LCUs. So 1 LCU per SCADA. So we can really steer per cluster, actually per SCADA, the lights. And 7 receivers are in place to detect the signals. And And it's then we will say something about the first point, because we have 7 receivers, we are able to make use of the multilateration technique. And I think my previous speaker already mentioned it very briefly. And multilateration means that you have in one place you receive on multiple places the same signal from a transponder. So, and because you have, in this case, 7 receivers, they all receive the signal on a very different moment in time, and because they are scattered throughout the wind farm, you can exactly determine the position of the aircraft. So it's I would say, a technique which is already there for decades. It was first there for the military. It was invented, but we also Lightguard also offers it here, made it available for ADLS, and it means that you can very exactly determine the location of the airplane, and that also allows us to have a very high lights off time, because you know exactly where the plane is, and if it's still in the vicinity but not in that zone of 5.5 kilometers, the lights will not blink. So that's also what we see, a very high lights off time of 79%, also in the first month. And yes, at the beginning we had some issues with connections in the turbine itself. And of course it should all work together. But what we really see now is dark nights in the polar, and we are very happy with that and proud of that. So it was a very nice cooperation between us, and also a lot of suppliers of wind turbines here involved. And it were wind turbines from Vestas, Nordex, and GE, and together we managed to make it the system work. My last point, what I already said, is a good location to apply this technique of multilateration, because it's very flat. Here we have no mountains, so that's ideal. A good line of sight, but also this body, the ILMT, allows for using multilateration. So that's very positive as well. So we're happy to further expand this and working on that with the projects upcoming. I would say so far the Netherlands. We go a little bit more north to my colleague Tobias from Scandinavia. So Tobias, the floor is yours.
Thank you very much, Daniel. I'm thankful for the opportunity to discuss the situation in Scandinavia today. Scandinavia in this presentation means Norway, Sweden, and Denmark. So it's not all of Scandinavia, but a substantial part. The development across all these 3 countries seems to be somewhat comparable. All these countries have seen a rapid and substantial expansion of wind industry over the last few years. And as a consequence, there is an increasing awareness of the safety implications for aviation. All these countries are currently working on a revision of their guidelines, both for the lighting systems and for ADLS. As Felix mentioned in the very beginning, there is a dilemma that the whole industry has to somehow fix. And this dilemma is that the aviation industry is arguing for maximum visibility of all potential obstacles, while the local population and the wind industry is arguing for the exact opposite, and is striving for minimal visibility. So this is a conflict of interests, but it's more than that. It is also a potential conflict of resource allocation and on what do I spend my money on. because the guidelines that are under discussion at the moment very often require a change in the lighting regime, different lights, more lights, etc. And while they often also allow for ADLS, you can only spend your money once, and you have to make a decision if you spend the money on more lights or on reduced light emissions. Everything I'm going to present over the next few minutes is work in progress, because in none of these three countries, the process of defining a final setup, a legal framework, has been finalized. It's all work in progress, and whatever I'm going to present today is the latest draft that has been floated around. Maybe we start with Denmark. Denmark has decided to consolidate all the different guidelines on lighting that exist into one comprehensive framework. And it does include updated lighting rules, and it also includes a framework for ADLS. The publication should have happened sometime in the past. It hasn't, but Denmark is going through a very comprehensive public hearing process. They have received lots of feedback from all stakeholders, and they are taking this feedback serious. They are having individual discussions with all parties, and they expect to come up with the compromise that ideally addresses all needs and expectations sometime next year. As I already mentioned on the next slide, there will be increased requirements for wind turbine lighting. And this is a comprehensive table. It's a comparison of the old regulation and the new. What we've highlighted is the changes that are either increasing light emissions or requiring an investment. So what we see in Denmark is that the draft of the future regulation will require turbines to have more powerful lights on top of the nacelle, not only at night, but also during the day. And for turbines with a tip height of more than 150 meters, there's also a new requirement to retrofit tower lights. So all in all, I think it's fair to say that the light emission from wind turbines will be required to increase when this legislation comes into place. There are some additional requirements like infrared, like flash synchronization, and also online status monitoring that indirectly require a lights upgrade. However, while there are increased demands for obstacle lighting, the regulation draft in Denmark also has guidelines for ADLS. In principle, it sounds like a solid approach. The ADLS guidelines in Denmark are technology agnostic, which means that it does not require a transponder-based detection technology or a radar-based technology, but it allows for whatever makes most sense. It has a detection zone and a lights activation zone, similar to what we see in Germany or in the Netherlands. So that's all fair play and seems quite reasonable to us. However, there is one point that is currently under intensive discussion, and this point is that the draft of the regulation requires wind turbines to always have a low intensity light fully lit on top of the nacelle as kind of a last resort, as a safety measure to warn approaching aircraft. And if this requirement will actually be be published, then ADLS in Denmark will not allow for a complete lights off. ADLS, according to this regulation, will be able to substantially reduce the light emissions, but it seems like there will be a requirement to always have at least a low intensity light on each and every nacelle. As I said, this is under massive discussion, and we're looking forward for this part of the regulation to go away. Norway actually has established clear rules for ADLS early in 2024. So there is a framework in place. However, this framework has shown to be very difficult to implement. And therefore, after feedback from the industry, the civil aviation authorities in Norway have decided to review and revise this existing regulation. There is a public hearing going on at the moment, and the CAA has indicated that an updated version of this regulation will be communicated beginning of next year. ADLS is not mandatory in Norway, but there are some wind farms with an ADLS requirement as part of their permission. Those ADLS should have been implemented almost 2 years ago, but the deadline has been extended to reflect the legal situation. If there is no clear guideline on how to do it, then it's very hard to expect wind farms to comply. So the current deadline for ADLS implementation is the end of next year. Like all the other countries, the Norwegian regulation is a combination of lighting requirements and ADLS. The changes in Norway are not as substantial as they are in Denmark, but they still lead to increased light emissions. The draft of the requirement requires the retrofit of low intensity lights halfway up the wind turbine, usually at probably 75 meters. And the draft of the regulation requires 2 reflective bands, yellow, highly reflective markings on the tower. So ADLS is just as important as a mitigation measure in Norway as it is in other countries. Next slide, please. And the regulation in Norway is interesting. Norway is the only country that we have seen so far that has at least dual detection approach. The draft of the regulation in Norway demands 2 different detection systems. One transponder-based for cooperative aircraft, and as some sort of last resort or as a catch-all technology, the use of radar-based detection for non-cooperative aircraft. The current version of the regulation actually requires a third technology, but we don't see that in the draft of the new one. So it's safe to assume that Norway will probably require 2 detection technologies working in parallel. However, this is going to play out. Accenture has executed a pilot installation in Norway earlier this year based on the current regulation. As I said, the current regulation requires 3 different detection technologies in parallel. A primary radar, which is this box on the picture in the the center, a transponder interrogator, a secondary surveillance radar, and a passive transponder receiver. The combination of those three technologies, as I said, is probably going to go away. However, we tested and piloted such a system, and we have shown and documented that the combination of different input sources and different sensor technologies is technically feasible and fully operational. So we're happy that we could prove and document in collaboration with the civil aviation authorities that their requirements can be met. When we look at Sweden, the situation is somewhat similar. They're working on a comprehensive guideline. Sweden, as opposed to the other countries, is not currently working on an ADLS framework. Sweden is currently working on a revision of their lighting regime. Also a little different to the other countries. On the next slide, it seems that Sweden is trying to harmonize the requirements. However, we do see that they also aim for more light emission rather than less. The future regulation draft is asking for a redundancy, so turbines currently equipped with only one beacon will have to be equipped with two. If the tip height is higher than 150 meters, there is the requirement of tower lights, just like we have seen in other countries. And there is a requirement for continuous online status monitoring. So if this comes into play, we will see more light emissions from the turbines, and we will see the requirement for online status monitoring, which as a consequence will require an upgrade of existing turbines. Now, I said that there is no ADLS framework in Sweden. However, there is a need to potentially retrofit lights. What we have therefore designed is a retrofit kit that meets the legal lighting requirements in Norway, in Denmark, and in Sweden. It is a drop-in solution that works without SCADA integration and is ADLS ready. So even if ADLS is not mandatory today, this lighting kit will make it very easy to retrofit ADLS in a later stage. The reason we developed this kit is because of the financial conflict between spending money on lights and spending money on ADLS. We believe we have put together a very, very cost-competitive solution here. And if any of you should be interested, it's a drop-in product that we can provide basically off the shelf. Having said this, this was my final slide. I think we're all looking forward to having your questions, and we're more than happy to answer to the best of our knowledge. Thank you very much.
Yeah, thank you, Toby, for the nice presentations. Thanks also to Daniel and Lorenzo. Yeah, as you can see, it's a quite complicated topic. It's a niche product we're very well aware of. Every country is cooking their own soup, so to say. So yeah, what we want to do is to offer ourselves as a full turnkey system integrator that can help with all the solutions in this environment. Yeah, Magnus, I would ask you to kindly moderate the Q&A. Please feel free to ask the questions if you have any into the forum. Magnus will then separate them by first come, first serve and give them to whoever of our speakers is probably best to answer them.
Will be my pleasure. So quick hello from my side. Thank you all for participating, and thank you for asking questions, which we already have a few of. And like Felix said, we will proceed in chronological order. So first come, first served. And without further ado, let's start into it. If you want to ask a question, you can do so via the Q&A or F&A tab. That depends on your language settings in Teams. And then you can ask a question also anonymously if you so wish. Specific questions for the countries I will ask to you directly, and questions that touch the broader subject of ADLS, I will refer to you, Felix. So the first question is regarding Austria. So it's a question for Lorenzo, and the question is, what is included in the monitoring and reporting for Austria? Is it similar or the same info reported as in Germany?
So thanks for the question. So we have a tool that is called OWL, where you can basically monitor if your LCU, so your light control unit, which is the brain of the ADLS system, basically, is online or not, for example. And also, there are some functions integrated. For example, are reporting on lights on and lights off times in the last 30 days, 7 days or so. For Austria, it might be that the platform looks a little bit different. It depends on the requirements. And also it depends on the kind of reporting that can be useful or necessary for the authorities. But overall, this is let's say, the main structure of this reporting tool, which is still under development for Austria.
Thank you very much, Lorenzo. And if I may add something, because you touched on the subject of OWL, our own monitoring tool, we gave a webinar on that 2 months ago, and you can find also the recording on our website if you're interested in that. So next question, I think that's from Greece, and it's yeah, on the broader subject, and it's regarding the military authorities. The question is, what is the point of view of the military authorities of the countries that have already applied ADLS? It seems like each country's CAA, Civil Aviation Authority, that is in the same line with the military. Is it so?
Yeah, it's a very good question. I can answer it with a yes or no. So the civil aviation authorities usually are the responsible bodies for permitting ADLS, but they have to take into account what the military is recommending, right? And yeah, as I said in the beginning of this presentation, they're the one that have to mediate this discussion, right? So the military is definitely one of the parties that is most interested in safety, right? Yeah, more to what the exact tasks are, like of the CAA and of the military, we can't say without having participated in the discussion. So we're very happy. Invite us. It's free, you can get a consultation from us, take us into the discussions. We have extensive documentation and also third-party evaluations by now on this topic. But I can assure you that this is what other countries also struggle with. Also in France, there is a very broad analysis at the moment of the Civil Aviation Authority and the military to what their approach to ADLS will be. And yeah, it's a long and complicated process. And we're very happy to support in any way that we can.
Thank you, Felix. So next up, we will try, of course, to answer all the remaining questions within the time we have. And if we do not manage it, we will overrun it by a few minutes so we can ask all your questions. And again, if you want to read along with me, you can just open the F&A or Q&A tab on the top. And if you wish, ask another question, but we do have a few more. And the next question is also a more general one. So I think to Felix, if I am uncertain with the possibility of ADLS, can you do an analysis for our wind farm or our country?
Okay, yeah. If you do not know whether or not you can apply ADLS, feel free to get in touch with us. Yeah, we are very happy to guide you along the process of making this possible for your wind farm. A lot of times in certain countries, it's asked project specifically. So right now we can only give input of the countries where we know that the issue as ADLS is solved country-wise, right? But sometimes local authorities ask for ADLS to be applied on a project-specific basis. This, for example, has been happening in the past in Sweden or also in South Africa, for example. Australia is a country like that. And if you're interested in a solution, or if your local authority has asked for ADLS to be implemented and you don't know what to do with the requirement, yeah, please get in touch with us. We see ourselves as a system integrator with experience in all these sensors. So primary radar, transponder, also secondary radar. So we will find a solution if you're in your wind farm.
Thank you. Next up, we have 2 questions regarding multilateration, and one is to Danielle, and the question is, why is multilateration only applicable in a horizontal situation as in the Netherlands? But before you start, Danielle, I will allow myself to rephrase it a little, because there is also a question afterwards regarding the advantages of multilateration. And also, I think there's a caveat, because multilateration is not only applicable in the Netherlands, but it works very well there. Correct me if I'm wrong, Danielle. Please take it away.
Magnus. That's exactly. I was also read the question. Thanks for that. And indeed, it's good to state that it's not. It can only be applied in the flat country of the Netherlands. So that's very important, especially also in mountainous area. It is a very good solution. It's more that we have a very good line of sight because there are no obstacles. So you can determine very well which airplanes are relevant and which are not. So it works very well in flat country, but indeed, good that you stated. And Felix, if you want to add it to the more mountainous country of Germany, just feel free to add. But that's good to rectify. And indeed, the other question, the advantages of using multilateration, I think number 1 is the high lights-off time, because you can have an airplane coming very close by the wind farm will still not make the lights blink, because the system knows it's not in the area, because it knows exactly where it is. So I think a high lights-off time is the most important one. But the second one, I would say, is also because you have more receivers, you can also steer your big wind farm in this perspective by clusters. So if an airplane is on one side of the wind farm, and only that lights need to blink, and the others can be left out. So also that is a very important one, that you can steer it within the wind farm because you have more receivers. But Felix, feel free to add something more about MLAT.
Yeah, I think you described it perfectly. If I can give a metaphor, so MLAT is not a yes or no, it's an optimization, right? So it's an optimization that can take place when you have enough receivers, so usually more than 4, that receive the signal, and then you can retrace basically where that signal came from. So, and it also works in mountainous areas. It's just that there, depending on the topography or the amount of receivers, it works at sometimes a higher level. So not you can't, let's say, optimize it as perfect and everywhere as in the Netherlands, for example, but only in certain areas. And so that means, it still works. It just works best with more receivers and flat topography. That's maybe how you can put it.
I hope, Martijn, this was a clear answer from our side.
I do think so. That was a very good and very clear answer. Thank you very much. We do have 2 minutes more and 3 questions more. So if you ask the questions, please stay with us. We will answer them all. Next one is a I think, a question that will be very short to answer. And the question is, can LightGuard offer a solution for every country?
In theory, yes, but we have to look at what the local authorities demand or what the local framework is. So I think this is something we've said before. In theory, we have the knowledge and the capacity to integrate whatever sensors is allowed or however aviation monitoring is taking place in that country. But we have to take a look at the local requirements.
Thank you, Felix. And the second to last question, I think that could be one for you, Tobias, because that came up during your part. And the question is, what is the purpose of the infrared light source on the nacelle? Is it an extra safety for the aircraft to detect a wind turbine? And what is the average range of such an infrared source?
That is exactly the point of infrared. Infrared lights have the advantage that they are invisible to the human eye. So a blinking infrared light will not annoy the residents. Infrared lights, however, will be visible to aircraft equipped with night vision equipment. And that should be most military or safe and rescue organizations. So with an IR-equipped turbine, the visibility for aircraft with the respective equipment is increased, while it is invisible to the human eye. And yes, this usually is a request from the military.
Thank you very much, Tobias. And that's 12, but we do have one more question, and we would like to answer it before we wrap this up and let you guys leave for the lunch break. So if you want to stay with us, we are happy. And the question is also a broader one, and it is, are there any known requirements for a certification of the ADLS system and its functionality in the presented countries? And if so, is LightGuard and partners, I like that, planning to receive those certifications for their solutions?
I think we can go through it for the countries that have a thorough law on it. So Germany, yes, there is a big certification process. We have certificates there. Austria, there is no certification needed for the authorities. So our approach is that we use whatever high standards we have in Germany to apply the same in Austria. And Netherlands, there's also a certification process. Yeah, maybe Daniel, you can go through it because we, of course, also obliged that one.
Yeah, and it's not so much the certification itself. Of course, we need the approval from the ILMT. So that's the official document that you get after performing the flight test. But actually, you need to prove that you adhere to the around 30 points from the requirements. And if you do that, and ILMT is giving this approval, then this, I would say, this is the certification way for the Netherlands. Yeah.
Thank you very much.
Yeah, Toby, is there anything you would like to add for the Scandinavian countries?
Yes, I believe when it comes to the required certifications, the picture is just as diverse as it is for the rest of the rules. It seems like every legislation has different points that they find most important, and the requirements will reflect that. In some countries, ADLS is considered part of avionics and has to meet the requirements of avionics equipment. In other countries, it has to meet the requirements of the lighting systems, of the beacons, and it's really hard to say. But the answer to the question is LightGuard and Central and all their partners will never install a system that is not compliant with the legal requirements. And if there are requirements, then we will make it possible.
Thank you guys for the answer, and thank you, Felix, for switching to the last slide, because you're taking the words out of my mouth. If you feel that there are any questions left unanswered, or if you want to get in touch with us, please feel free to scan those QR codes, which will lead you to our websites, Lightguard for Felix, Lorenzo, and me, Topwind for Danielle, and Center for Tobias and Scandinavia. And yeah, we hope to hear from you soon. We want to thank you very much for sticking with us through the end and participating in our webinar, and for all those questions. Of course, we will be happy to send you the recording as well as the presentation afterwards. You will get it this afternoon. And yeah, I want to wish you, on behalf of all of us, a successful end of the year, a Merry Christmas, Happy New Year, and we hope to hear from you soon. And of course, special thanks to our speakers, all of you, Felix, Lorenzo, Danielle, Tobias. Thank you.
Yeah, thank you, Magnus. Thank you all for listening.
And bye-bye.
Thank you.
Bye.
Thank you. Bye-bye.
Thank you very much. And that wraps it up